Hi, this is Mr. Ward, and I'm going to do a video walkthrough of some of the problems in 8.4. So the first problem you need to do, so you're supposed to do 3, 5, and 7, 12, 13, and 14. You had a choice of 16 and 17, and do 21. So I believe I may have assigned some exceeding problems. I'm just going to focus on these. If you would like a walkthrough of exceeding ones, let me know. So we'll start with number 3. So we've been given angle X is congruent to ZBA. So this angle and this angle are congruent. I'll go ahead and mark that because it's always useful to mark what we know. So those angles are congruent. And we're trying to prove that AZ, so AZ, this side here, is to AB as ZY is to XY. Okay, so we're trying to prove AZ, so AZ is to AB as ZY is to XY. All right, well, so what that really is getting at is we need to prove, if we can prove that ZXY is similar to ZBA, then we'll be able to do this. Well, the nice thing is they share an angle right here. So by angle, you'll be able to prove that ZBA and ZXY are similar. And so let's look at AZ. Okay, if we call this AZB, that might make it a little easier. So AZ is going to be in the same position. So AZ is going to be the same position as ZY. So AZ is from, A is the angle that we haven't pinned down yet, but since we now have all of that, let's go ahead and pin it down. So that by no choice, and that by no choice because we have two angles. So AZ is between the green and the blue angles, and AB is between the blue and the red angle. So then if ZY is between the blue and the green angle, so let's find ZY, that is between the blue and the green, and XY is between the blue and the red, then we have corresponding sides of these similar triangles. And so they will definitely make a proportion. So number 5, I'm going to scroll down just a little bit here. For number 5, we've got HJK is a right angle. We've got JM is an altitude. And we're asked to prove that JM is to MK, so that's setting up this triangle JMK, as HJ is to JK, and that's setting up the triangle HJK. All right, well, we have been given some information about angles. We know this is a right angle, and we know this is a right angle. Now, HJK and JMK share another angle, which is over here. And therefore, their remaining angle has to be congruent to by no choice. I didn't need the other angle to label it, but it's going to be easier for me to remind myself what the corresponding side relationships are when I do that. So JM is from blue to right, okay? And HJ is from, okay, so let me see that. What am I saying? I apologize. JM is from green to the right, and HJ is from green to the right angle, green to blue. MK is from right to red, and JK is from right to red. So we've got corresponding sides, and these triangles are definitely similar. So HJK and JMK are similar. So JM is to MK as HJ is to JK because they are corresponding sides of similar triangles. Number 7, we have WZ is parallel to XY. And so we're asking to prove that WS times XY is equal to XS to WZ. All right, well, because those are parallel, we can definitely say that these angles are congruent because it sets up a transversal. These angles are congruent, they're corresponding angles. And then finally, S is itself. So we have two similar triangles, SWZ and SXY. So we can set up, okay, let's see, WS here is going to be to XS. Okay, so let me grab this one. So WS, we can say is to XS for similar triangles, as XY, okay, XY is for the big triangle, so we're going to want to use the WZ, as WZ is to XY. So small to big helps us organize it all. And so WS times XY, that's the product of the extremes. XS times WZ, that's the product of the means. So that's the means extremes product theorem. All right, let me take a look at our next one, which is 12 and 13, and then 14. So let's go over there. I'm going to move my face over here, and let's scroll up to, well, there we go, 12, 13, and 14. All right, 12, we've got a parallelogram. As soon as we have parallelograms, we have some possibilities of congruent angles. So we know that ABH and EFD are congruent. So let's label that. I'll use orange. So ABH and EFD are congruent. And it's a parallelogram. We're asked about AH and FD, AH times FD, and HB times E. Oh, okay. That's interesting. So AH and FD, so AH and FD, and we're asked, let me just confirm the angles, ABH and EFD, good. We're asked about AH and FD. That's interesting. And then HB and ED. Okay, yeah, AH and ED. Okay, so what we know, since it's a parallelogram, is that the opposite angles are congruent. So we have similar triangles right off the bat. I'm going to go ahead and label the third angle here to help us keep corresponding sides in order. Okay, so I'm going to use black for that. And so we're dealing with AH, so let's take a look at AH. So let's see which side on the other triangle AH corresponds. That's green to blue. Green to blue is to ED. Okay, and then we're also dealing with FD and HB. So HB is on our first triangle, so I'm going to stick with that. HB. So HB is from blue to orange, and FD is blue to orange as well. So we have the setup. So I find it really useful to set up the proportion first. And so now AH times FD will equal ED times HB. And so you're good. I'm going to pause for a second. So that's number 12. Let's look at number 13. So we're going to prove corresponding altitudes of similar triangles are proportional to any pair of corresponding sides on the similar triangles. Well, here's the deal. If you draw altitudes, you're making right angles. And you're also splitting a triangle into two triangles. If the altitude happens to be on the outside, then you are going to be having a right angle to a new triangle that's produced by an extended base that has an angle that is supplemental to one of the angles of the two similar triangles. And so that will also work as well. It probably helps to draw these things. So let's do that. So I'm going to draw two triangles like this. Okay. And we'll label our angles flump and flump. And make that flop and flop. And flippity and flippity. Okay, so the blue. And now I'm going to drop an altitude, flump and flump. And so I have immediately set up a situation where either side of this triangle that I've split up is going to have, so this triangle is going to be similar to this one, and this triangle will be similar to this one. So it's going to be fairly easy to prove that the side, the altitude, is going to have the same kind of proportional relationships that the sides of the any of the now, so this big triangle or the left side or the right side triangles will have. Now 14 asks us to prove corresponding angle bisectors of similar triangles are proportional to any pair of corresponding sides in the similar triangles. And we can do that pretty easily as well. So I'll draw a triangle here, and I'll draw another triangle here, and that's a triangle. It really is. Okay, so I've got this angle here and this angle here. And if I take this angle here, which I'm going to make the green angle, okay, those are congruent, and I bisect the green angle, flop and flop. I am bisecting the green angle by division. Each side of this one is congruent to each side of this one because I'm dividing the congruent angles in half. And then I've got another angle here and here, or I've got another angle here and here. And so either side of these triangles, so this side and this side will be similar, this side and this side will be similar, because I'll have angle, angle, and angle, angle, and angle, angle forces angle, angle, angle. Number 16 and 17. Let me pause and pause for a second. All right, I have magically moved the page. So here we are on number 16 and 17. So we've got this trapezoid ABCD with bases AB and CD, which means those are parallel. And then we've got this statement we want to prove. AE times CD, AE times CD is EC times AB. Okay, so what you need to do is you need to prove that this top triangle and this bottom triangle are congruent. And we can do that pretty easily based upon the fact that a trapezoid has parallel bases. So that's an alternate interior angle. And I'm going to label this as another alternate interior angle. And for total overkill, I will go ahead and identify the vertical angles. So we have angle, angle, angle. I only needed any two of those. And so we can say, so we've got AE. Let's find AE. There's AE. So AE is from yellow to green. AE will be to EC or CE. We're going to use EC because that's the labeling they used in the problem. And then we've got CD and AB. So CD and AB. So AE is on the bottom triangle, so I'll use AB on the top. So AB here. AB will be my numerator. is to CD, which is also from yellow to blue. And there we go. We've got them equal. And so AE times CD will equal EC times AB, and that's a match. Ooh, yay. So that's what you got to prove. And with all of these, of course, I'm walking you through it, but you got to write the proof. Okay. And you should pause whenever, you like, and then you can come and see how you did with it. I'm going to now take a look at 17. So 17, we've been given that M and S are congruent. So I'll label those. So M and S are congruent. Okay. And, we will, of course, know that these are vertical angles, so those are congruent as well. And by no choice, we can go ahead and identify these as congruent too. So we definitely will know that MOP and SRP are similar triangles. So we know that MP is 8, so that's 8, and PR is 6, and SP is 7. We want to find PO. Well, MP is to PS as OP is to PR. So we can just set that all up, write it all up. So MP, which is going to be 8, MP is to PS, or SP, 8 is to 7, okay, as, and then PR, so 8 is to 7, as OP is to PR. So OP, that's our missing one, is to PR, which is 6. So we can use the product of the extremes and the product of the means. So 8 times 6 equals 7 times OP. So ultimately it'll end up being 48 over 7. Okay, 8 times 6 equals 7 times OP. We'll end up doing 8 times 6 divided by 7, which will equal OP, and you'll have it once you've worked all that out. So I'm not going to finish working that out. I'll let you do that on your own. And now let's take a look at 21. I'm going to pause, and I'm back, and everything got bigger. So given that ACB is a right triangle, okay, so we can label that. I'll label this flump, flump. There's a right angle, okay, and so that's a right angle, and CD is an altitude, so that makes another right angle, and right angles are congruent. We're going to prove that CD squared equals AD times AB. Well, here's what we can do. We can say that this angle here, okay, we can do that, and then we can, so it's labeling that angle, and then we'll also label this angle. Those two angles happen to be complementary because this angle is a right angle. But if this triangle here has a right angle and this angle, so this angle here has to be complementary to this as well, which means it's congruent to angle B. And this angle is complementary to B because it's a right triangle, and so we can go ahead and label this angle here like that. So now I'll go ahead and do that as well. So CD is for this triangle from yellow to blue. And for this triangle, it's green to blue. So they're in different positions for those two triangles. We've got AD and DB. Okay, so AD is yellow to blue and DB is green to blue. So I'm going to go with yellow to blue. So I'll say, write it in black. So we're going to have AD, yellow to blue, okay, for this left side triangle, is going to be from yellow to blue, is going to be as CD. Okay. for the triangle over here. So for this left side triangle, A to D is yellow to blue. The right triangle, it's CD is yellow to blue. And for the left side triangle, we're going to say CD is green to blue. So CD is green to blue. And DB, hang on a second. And AD, hang on a second, I'm losing track of things here. So I know this side corresponds to CD. But CD, so yellow to blue, as yellow to blue. And then CD now for the left triangle is green to blue as green to blue. So that's what I want, DB, like that. So I went yellow to blue to as to yellow to blue, as green to blue is to green to blue, for large to small, large to small. And now I've got CD squared equals AD times DB. And this is actually the foundation of the altitude on hypotenuse theorem that shows up in chapter 9. Okay, and that is that for this chapter. I hope that was helpful.